Okay, here are the video solutions to week 8, um, lessons 3 through 5. And so let me just start with number 1 here. Select all points where relative minimum values occur on this graph of a polynomial function. So relative minimum values are those that are minimums relative to the points on either side of them. So it looks like B is a relative minimum on this graph. It's minimum here. And then also E over here I would consider a relative min um, because it's a minimum. The graph dips down there. So it's a minimum with respect to the points around it. But that's about it for that one. Number 2, add one term to the polynomial expression, 14x to the 19th minus 9x to the 15th, and so on, to make it into a 22nd degree polynomial. I think you could just add x to the 22nd. And now it's a 22nd degree polynomial. Number 3, identify the leading coefficient or the degree, the leading coefficient and constant value for each. So for the first one, the degree is 3. The leading coefficient is the 1 because there is no number in front of the x cubed, so we know that it's a 1. And the constant value is 8 in this case. For the function h in letter B, our degree is 4. That's the highest degree there. Our leading coefficient then would be the 2 because that's the coefficient of the x to the 4th term. And then the constant is 1. And for our function g in letter C there, it looks like our degree, so these are not, it's not written in standard order. We have a 4th degree term there as the second term. So that would be the degree of the whole polynomial. The leading coefficient would be 3, the coefficient on that x to the 4th term, and the constant is a negative 4.4. Number 4, here are two expressions whose product is a new expression A. Andre says that any real number can go in either of those boxes and A will be a polynomial. Is he correct? And he's not correct. Remember, the exponents have to be whole numbers, and so this would be a no. The second box must be, and if these are going to be whole number exponents, when we multiply this times this and this times this, when we distribute that, if we add exponents, we could have a negative over here with the 4x to the power in order for us to get a polynomial, because when we add exponents, if this was a negative 4 up here, we would get 0. So, but we'd have to have it be greater than or equal to negative 3 because we can't take away more than 3 from this exponent, or else we'll get into the negative exponents and that won't work. So here, the second box must be greater than or equal to negative 3. Number 5, Lynn divides the polynomial 2x squared minus 4x plus 1 by 4 and gets the 0.5x squared minus 1x plus 0.25. And they're asking, is 0.5x squared minus x plus 0.25 a polynomial? And that is. Our coefficients can be real numbers, and our exponents have to be whole numbers when it's written in standard form like this. So this is yes. Um, Coefficients can be fractions. And then we know that all the exponents are whole numbers. So this is a polynomial. Number 6, what's the result when any two integers are multiplied? Whenever any two integers are multiplied, we don't always get a positive one because we have that case where negative times a positive is a negative, so that's out. We don't always get a negative either because when they're both positive or both negative, we get a positive. But we do always get another integer. So your answer there would be C. Number 7, Claire wants to make an open top box by cutting out corners of a 30 by 25-inch piece of paper or poster board and then folding up the sides. So this is, we're getting pretty used to this scenario and this function. So the expression for the volume of that box would be V of x is equal to, and then we would take one side length, which is 30. We have to subtract 2 times the length of that little square that she cuts out. And then we multiply it, so that might be the length. And then the width would be 25 minus 2x. Again, same reasoning. And then the height would be x, so we have to multiply that in there too. And so what is a reasonable domain for x, or for v for that function? Well, we can only cut into that, the shortest side is 25 inches, and we can only go into that, at most 12 and a half of 25. So I would say x has to be between 0 and 12.5 then for the domain. We don't need to talk about anything more because we wouldn't be able to make a box then if we did anything greater than that. Number 8, identify the degree, leading coefficient, and constant values. So the degree in this case is 5 for letter A. The leading coefficient would be 2 because that's the coefficient on the x to the 5th term. And the constant is -6 there at the end without any variable attached. For function h, we have x cubed minus 7x squared minus x plus 2. So the degree is 3. Our leading coefficient is 1, and our constant is 2. For the function g, in letter C, we have, again, this is out of order, but that's our highest term, so our degree is 3 here again. Our leading coefficient is -4. Be sure and take the negative sign with it. Think of it as adding a negative, this subtraction. We could change this to plus a -4/3 x, and so that's how I think about it. And then our constant term is 5.4. Number 9, which point is a relative min? The only point that's labeled that's a relative min would be point A. There is another relative min down here, but they don't have it labeled. Number 10, what's the value of this this polynomial or this factored polynomial when x is equal to 5? So if we put 5 in here for x in this first grouping, we get 4 times 3 times 2. If we put 5 in over here, we get 0, and that wipes out this whole term. And if we put 5 in down here, that we get 0 again. So we really only have to worry about the 4 times the 6. And so at x equal to 5, the value is 24. Number 11, which polynomial function has zeros when x is -2, x is 3/4, and x is 5? So it must have looked like this: x plus 2, x minus 3/4, and x minus 5. when it was factored. And so that one would be letter D. Number 12. The graph of a polynomial function has x-intercepts at 3 x values. What are they? So this is similar to the one up here, but going the other way. If we set each of these equal to 0, 2x minus 3 equal to 0, let's do it up here. We would add 3 to both sides. We'd get 2x is equal to 3, and then divide by 2, and we'd get x is equal to 3 halves. So that first one is x equal to 3 halves, the first solution, or 0. What do they call it? X-intercepts is what they're calling them here. Remember we said we could call those zeros or solutions as well. The next x-intercept would be from this, if this factor was 0, and so the x value that makes that 0 is just 4. And then another solution, or 0, or x-intercept, would be where this factor is 0, and that's at x equal to negative 3. You can just tell that by inspection there, those last two. 13, match each sequence with one of the recursive definitions. Note that only the part of the definition showing the relationship between the current term and the previous term is given, so as not to give away the solutions. One of the sequences matches 2 recursive definitions. So for letter A, to find a of n, it says take a of n minus 1. So take the previous term and subtract 4. So this is the previous term in our recursive definition. So that looks like number 1 down there, 7, 3, negative 1, negative 5. We keep subtracting 4. Letter B, it says take the previous term and add 0. That looks like it could be number 3 down there, 8, 8, 8. We're just adding 0 each time. Letter C says take the previous term and multiply it by negative 1/2. I would say that would be the second sequence down there. And then the fourth definition says take the previous term and multiply by 1. So that would fit for number 3 also, the one that goes 8, 8, 8. So that one had 2 rules that would apply. Number 14, Han is multiplying 8 or 10x to the 4th by 0.5x cubed and gets 5x to the 7th, which is great. He did that correctly. He says that 0.5x cubed is not a polynomial because 0.5 is not an integer. What's the error in Han's thinking? Well, Han is making an error because he's thinking that the coefficient can't be a fraction, but it can. The coefficients can be any real number. It's the exponents that have to be whole numbers. So coefficients can be any real number. Okay, number 15. Here are 2 expressions whose sum is a new expression. So select all the values that we can put in the box so that A is a polynomial. If we try negative 2 up here, when we multiply 6 times 2x squared, we'll get 12x to the 0, which is just 12. That's okay. But when we multiply 6 to the negative 2nd power times 5, we'll get 30x to the negative 2. And that won't work because we have to have whole number exponents. We can't not have a negative exponent or a fractional exponent. If we put negative 1 in there, the same thing will apply. If we put a negative 1 here, we would get 2x squared times 6x to the negative 1 would be 12x to the positive 1. But then when we multiply here, that's where our red flag comes up. We can't have that. So b is equal to negative 1 does not work. 0.5, we can't have fractional exponents. And when we add 2 and 0.5 here, we'd get 2.5 or 5 halves. So this would not work either. A 0.5 there doesn't work, a negative. 0, I think that'll work because that's just like multiplying by 6. So this would work. And then E, again, we're going to get 1.5, or 2, that's where we'll get 2.5. This was been 1.5. Sorry about that. But anyway, we can't have fractional exponents. F works, that's fine. G works. So really be careful here. Even sometimes it'll work. You know, if one of them is negative, as long as when you multiply it back out, then you get all whole number exponents. Is that it? Looks like it. Okay, I hope this helped. Thanks.